Before we begin, remember that any new exercise program should be cleared by a medical professional. But if you are ready to train, optimizing your lower body mechanics is a high-return investment for your long-term physical health. Our goal today is specific. We will build resilient knees, improve hip mobility, and strengthen the lower body. To do this, we are going to break down and master one highly effective movement pattern, the heel-elevated lateral squat. If you want to keep improving your mechanics, hit the subscribe button below so we can continue bringing you science-backed movement tutorials. Traditional strength training relies heavily on moving straight forward and backward. By shifting our training to a side-to-side frontal plane variation, we engage the lateral stabilizing muscles that prevent energy leaks and protect your joints from premature wear. Step 1 is understanding how the body distributes mechanical demand. A standard forward lunge occurs in the sagittal plane, loading the hip joint in a straight line. A lateral movement forces the body into the frontal plane, meaning the load is distributed asymmetrically across a completely different kinetic chain. This 3D model of the lower kinetic chain illustrates exactly what happens when you step to the side. You engage the adductor magnus on the inner thigh to control the descent. The gluteus medius fires on the side of the hip to stabilize the pelvis. Finally, the quadriceps take on the primary load to extend the knee. Now look at the geometry when we modify the stance. In a flat-footed squat, the shins must tilt aggressively forward to reach full depth. But by elevating the heel, the ankle is placed in a state of relative plantarflexion. This allows the knee to glide forward smoothly, keeping the torso completely upright. This elevation solves a strict mechanical limitation: tight ankles. If your ankle lacks dorsiflexion, your shin cannot tilt forward. To stay balanced, your body forces you to lean your torso forward, shifting stress away from your legs and directly into your lower back. Placing a wedge under your heel removes that mobility roadblock. It allows you to maintain an upright posture and drive the resistance directly into the quadriceps, isolating the exact muscle group we want to strengthen. To apply this mechanical advantage safely, we have to respect the physical stress continuum. Stress on a joint is simply a physical stimulus. Apply too little and the tissue weakens. Apply a progressive, controlled load and the joint adapts to handle greater force. This sequence illustrates how rigid structures must develop tolerance to physical loads. For decades, standard fitness advice dictated keeping the knees strictly behind the toes. However, biomechanical data proves that building joint capacity requires training the knee to travel forward under controlled conditions. Clinical rehabilitation protocols rely on this exact mechanism. Gradually increasing the distance between your knee and your center of mass increases the specific force on the patellofemoral joint. This forces the cartilage and surrounding connective tissues to adapt and distribute loads more efficiently. Conditioning your knees to handle these deep ranges of motion now directly determines how easily you will get out of a chair, walk upstairs, and maintain your physical independence into your 60s and 70s. Before we attempt the full heel-elevated lateral squat, we need to establish a baseline for balance. We will start with a simple box squat to a chair or bench. Stand with your feet slightly wider than your hips. Lower your hips back and down until your glutes tap the surface, then stand back up. Do not sit completely down. The goal is to map out a proper center of gravity. This primer specifically trains the eccentric phase, the controlled descent of your body weight. Having the box directly beneath you removes the psychological fear of falling, allowing you to focus entirely on muscular control. Once you can perform these repetitions smoothly, your neuromuscular system is balanced. You are now prepared to manage the asymmetrical instability of the lateral stance. Let's build the main movement. Take a wide stance and place a wedge or a weight plate directly under the heel of your working leg. Check your alignment. Both feet must remain firmly planted and point strictly forward. Allowing your toes to slide outward alters the joint angles and reduces the activation of your hip stabilizers. Begin the descent by shifting your body weight entirely onto the elevated heel. As your working knee bends, keep your opposite leg completely straight. To return to the top, drive force directly down through the elevated foot. Push the floor away to bring your torso back to the center starting position. Look at this geometric overlay to spot the primary failure point, leaning the torso too far forward over the knee. Let the wedge maintain your posture. Keep your chest tall and your spine aligned on a vertical vector. Strict adherence to this geometry isolates the targeted leg muscles and protects the lumbar spine from shear stress, transforming an unstable position into a foundation of strength. As your body weight begins to feel manageable, you must scale the movement with external resistance to trigger new muscle growth. The most efficient way to progress is by holding a dumbbell or kettlebell at chest height in the goblet position. Placing this load anteriorly forces your core to brace against the weight to keep you upright. This stable core allows you to drive significantly more resistance into your quadriceps and glutes. Progressive overload is the ultimate requirement. Systematically adding resistance ensures your initial movement practice translates into lasting structural strength. By deconstructing the mechanics of a single movement, we have established the technical foundation for lower body resilience. You can now bypass ankle stiffness, optimally target the quadriceps and adductors, and condition your knee joints to tolerate the forces of active daily living. If you found this biomechanical breakdown helpful, please subscribe so we can deliver more technical fitness guides straight to your feed. Then head down to the comments and let us know how your knees feel after testing out this elevated stance. Intelligent, science-backed biomechanical modifications provide the foundation for lifelong athletic longevity and daily physical freedom.